All right. Okay. So you can create an empty file here. Let's go through the contents we're gonna do this week, basically. Well, first, let me go through the concept of the foldable, which is really easy because I'm going according to the FantasyLand specs. This is what I need actually to go through the contents to make a very simple program working today, if not next week. So foldable is anything with a reduce method on it. If I open FantasyLand specs, let's have a look. Foldable is kind of a lonely guy here. It's a type called foldable. Yeah. Here it basically says if something is a foldable, that means you have reduced method on it. Okay, and as you can expect, it will be the similar signature is the reduce function method on array. Let's increase the size on this. Okay, the function takes a cumulative value first and the current value of the iteration if it's an array, and then it does concatenation and it takes the initial values. Here it says the reduce on list with concatenation is actually itself. Just reconstruct the list, reduce to itself. This signature is FantasyLand syntax, a bit of a Haskell syntax mixed. What it does to this is very important for us to understand. The signature here is a curly. First, we need to explain this thing. The curly large than. That means this parameter is the this in JavaScript. This.
Oh.
Yeah. Okay. That means the U here is this FA. Yeah.
I have a question. So the order is from right to left, right? This reduces from right to left.
It should be.
Yeah.
It should be.
Because the normal reduce in JavaScript is left to right.
Left, right.
So this is right to left.
Yeah. Yeah. It should be right to left. Yeah. Yeah. The formal definition in Haskell is actually specifies that order as well. So yeah, just keep that in mind. So the curly large then, what it means is you see the reduce here, it should be taking the FA is actually the implied parameter, right? It's a method. So this U is actually available to this reduce function. Correct? In JavaScript, that we call method, but this is actually available everywhere inside the method. Yeah. So that's what the curly large then means. So the FA is the object you're calling the method on.
Oh, okay.
Okay. So that means whatever here is actually what this part. The reduce takes a function first, is that F. And the B is the initial value, which is that X. And produce the result, which is the B. They all types, right? The A and B are all both types, not value. So it's not like 1, 2, 3 or string or like literals. No, like they are types. It could be A, could be a string, could be a boolean, could be many things. Yeah. So it means like for any type, for all A's, A is any type, basically.
You send the tutor arrow. That is this, right? I mean, is that yeah, that part is. What do you mean that this?
It's a bit confusing. Yeah. Let me draw this. So you have a foldable the object which you can call reduce on it, and you have this reducer here with a f initial value. Right. So it tries to express the type for this one. Right. In functional programming, there's no method basically. There's function. Or Scala is one with method. But anyway, I'm talking about Haskell. It's only function, right? It doesn't have like dot.
Okay.
So if I only have a reduce, the type for it is this double column. It means type. The type of reduce is right, let me just simplify it a little bit. FA and BA to B and initial value and to B. Okay. So because that means this reduce this function, not this method. This function is to take U first, right? And then takes the F, and then the X, right? It writes like, it could be like this, but it writes like this, X. If you curry it, it will be X. Yeah.
X means the B, right?
That B.
Okay.
Yeah. But in functional programming, you wouldn't do this because almost all the function takes function first and then the value second, right? Like the prop, the path, or takes the path first and then the actual value you want to work with second. Yeah. So you will have FA put in here. In here will be FA. We'll just get rid of that, something like that. Maybe like that. In functional programming, basically you do this normally. But in JavaScript, because it's FantasyLand spec, it express this method, not function. So how does the type signature to reflect this kind of a structure is to say, let me just get rid of that, is to say this FA is implied because you dot, because I'm calling a method. So I'll just do, that means whatever before it is implied, the U here. No?
Yeah.
FA.
Almost.
Almost? Yeah. So the reduce.
Yeah. So which means I think my understanding is the right part just means you can take everything from the left side, invoke itself.
Yeah.
So it's not a simple function, but it's kind of like you can call something.
Yeah.
Apply the value to itself based on the object which you take.
It's to do with that. If you just get rid of that, that looks very similar to, right? That's F, that's the X, and then produce another value, right?
Yeah.
That's what reduce does.
Yeah.
How do you express that in object-oriented programming, basically?
Okay.
Is to say, okay, this reduce does not take any more parameter, but what's the thing you need to reduce? But if it's an array of 1, 2, where is that thing to express here? Nowhere. So they come up with this notion to say, let's just put it here.
The F means function. What does the A
No, this is
The whole thing?
the whole thing.
Yeah.
Yeah, the whole thing. So that's what I say is simplify it. It has a foldable, I'll get to it, foldable F. And then it says, is reduce. And it says FA, right?
Yeah.
Yeah. Okay. So let me explain this. We talk about this. This is the type of reduce is. Yeah.
Yep.
This this fat arrow here, it means dependency. It means the left side is the dependency for certain things on the right side. In this instance, it is the f on the right side is a foldable. It puts a constraint to say the f, when I express the type signature on the right, the f, every time it appears, it will be a foldable.
Okay.
It just writes like formally like this. In Haskell, you write things like this. That means the foldable itself is what we call a type class. Now, what does that mean? That means it expresses a class, let's say a bunch of type, which all have certain characteristics on them. It's like interface. Well, you think about interface first when you're coming from OO, but it's more than that. But if you think about it as an interface, to say f is of this interface, what does this interface give you? It says it must have a reduce on it. That means f plus whatever type it contains needs to have a reduce method. Reduce method on it. Okay. Why don't I say, can I say f is an array? That means you have a concrete kind of example for that kind of type, type class. And you may have a tray which is foldable, right? If you provide a reduce on the tray structure, right? Later on, we'll say maybe structure is actually foldable as well. There's no looping, there's no tray structure. You can actually make it foldable. So this is expressing as a reduced function available on every single instance of f. Yeah. It just expresses the constraint.
Yeah. So it has a reduce feature on this foldable thing.
Yeah, the foldable, according to FantasyLand spec, every single foldable needs to have a reduce method.
Okay.
Yeah,
Okay.
that means FA, which in this sense is the this in reduce.
The A
That
means,
itself, it means this has a reduce means it provides a reduce
is
method.
that what does the A indicates? Is A just
Okay, all right. A.
I don't know.
Now we going to this, what is F? Why they are a group, but here it's just single letter. This means this is exactly I want to explain this time. The F is a container. Let's just picture it as a container.
Yep.
Okay. A is whatever type, the type of value inside that container. Okay. Let's say array is a container. In this instance, it contains integer, right?
Yep.
So to express this, you have array of integer, right?
Yeah.
Now, I can also have array of strings. Array. Bear with me. Strings. Okay. Now, how do I express array of any type in particular? Not mixing them, just one type, but I don't know what type it is. How do I express that? I say
Array A.
yeah,
Array A. So the
array A.
A means any.
Any, yeah, it is any.
Any type in particular, only one type. Okay, so this doesn't mean no.
We can't do that.
We can't do that. The A means a single type, but any type.
Yeah.
A single type.
Right.
So
Yeah.
actually, the formula behind that is also types. The B also types.
They all types.
Okay.
Because it describes a function. This is the type signature. There's no value here.
Okay.
Now F, if we treat array as a container, then we have different container. We can say, let's say I have a class called tree, which is like this. Right?
Yeah.
That's tray of integer. You know where this goes, right? So tray of strings,
Yeah,
tray of A.
just different structure.
Yes. So comparing this to that, this is horizontal, right? Comparing this column, you may have different things here, right? All integers. Then you have f of integer.
Yeah.
F of strings. The f means that container,
Okay.
correct?
Yeah.
Then here you have fa.
Whatever. Yeah.
Whatever container contains whatever value.
Yeah.
So that means a container contains a value,
Okay.
that type of that value,
Yeah.
particular type, not any type. But I don't know what type it is, so I use A. It could be any type, consistent. Now that's foldable, and then this leads to another thing we call Functor. So what, please? Any question?
So the B is also another type?
Yes.
Or
Well,
we-
not entirely. B could be the same type as A,
Okay.
but it's a
Can
one
it be,
particular type.
can it be different types? As A is string and then the B
Yes,
can be.
it can. The reason I name it A and B, if I say A, it means all the same type. But I don't know which type it is.
So A is not the value, it's the type.
Yeah.
So A,
But-
B should be different type. Or
Um,
Maybe different
say-
type.
Okay.
Okay, so it could be the same type. It could be different type.
I see.
But this B and this B, this B, this B are all the same type. And this A and this A are all the same type.
So the BA arrow BB means transfer BA to.
Yes, so it's a function. This thing is a
Oh,
function.
that is function.
That's a function.
Okay.
That's the input.
Mm.
That's the output.
Oh, okay.
That means
So they transfer the type from A O to B.
you have a function transfer takes A B A as a pair
Yeah.
in and produce a value of type B. Yeah. In your reducer function, basically you have the current state. Which one? Forgot. Your current state and your action. Right. You produce state again. Right. That's your initial state.
Oh.
Yeah.
Yeah.
You're basically doing a folding on your well, it's called reducer, right? So yeah, the reducer is that function. Okay. And the state and state, that type matches that A is the action. So okay. Gonna wipe it. Okay. Now I want to talk about another a particular another type class. We have a foldable, which is a type class, right? Now we have Functor as a type class. A type class take another type and essentially to construct things. But in this case, what is a functor? Let me just start with examples. Let's call it list, because in Lambda we call things list instead of array. Maybe list is a better name. So let's think. We explain the count. That's the in type wise we say the square bracket is the container, and you have a type in there. And the functor, like foldable, you need to reduce. Any foldable instance, the object which is a foldable, have a reduce method on it. Every single functor, you have a map on it. Okay, so here's the important part, the signature for map. So we discuss reduce, right? Now we discuss map. Map, the type for map function is, we take, I'm just thinking, should I write a function signature first, not a method? So it takes a function first. This function transfer A to B. Any question, just ask. If you don't understand this is crucial, right? It's a function, it takes a function first. Let me just put a bracket here to make it clear. The first parameter is a function, and then takes a FA, container of A. In the sense of list, it will be a list of A. And it produce, the return value is a container of B. Yes, in the list sense, it will be just a list of B. So this is a generalized version. Now, if you use FantasyLand, that means what? You're calling a method, right? Calling a method, you have data first. You have FA first. Yeah? And then you take a function from A to B, and you produce FB. This map is equivalent to say I take a function, and then in the case of a list, it will be like this, right? And this would be 1, 2, 3, the map. Yeah. Here, just the difference like this. In this form, you can only chain dots. In this form, you can compose this part.
Yeah.
Compose this part.
So the second one is the FantasyLand.
FantasyLand. Yeah, you can convert them. Yeah.
What is the first one for? I mean, is another spec or general?
Well, normally in function programming, you write this.
Oh, okay.
Yeah. Yeah, it's more.
The Lambda is using the first one. Right?
Lambda has a map.
Right.
Which is using this one.
I think the ES, I mean, in the JavaScript, it's the second one. Right?
Yes, it's the second one.
Yeah. Okay.
But this one, you can't really compose when you call it. Why? Because you're already operating on data structure.
Yes.
Yeah, your data has been. This is more obvious to say what's declarative programming. That means you already executing your computation. You're not describing it and later on compose and then calling it, which is execution.
Yeah.
Here you're already doing that at the same time. Yeah.
So if you call a flip, it will be equivalent to.
Yes, if you call a flip, not really, because normally you only convert this to that in order to be able to compose. That means, let's say in the sense of array, you have an array, right? You have a function, and then you have an array, and you do. Then this one is the one. Yeah? You just convert it like this. In Lambda sense, you can do invoke. So invoke. Sorry. Map. Where is map? I think there's a 1 here. It takes 3 parameters to do this, I think. And then you just pass array here. 1, 2, 3. I think this is equivalent to
Is that run the function invoke?
Invoke. It's just
Invoker.
invoker.
Yeah.
I'm not sure I wrote this correctly, but more or less, I don't really do invoker because it looks really ugly. Variables. Yeah. So just get rid of it. Yeah.
So which way is more recommended in?
This way.
Is more recommended.
Yes. You composition. You know, there's only three things you look at: the types, the function, the composition. Right? We talked about last time. So if you can compose, you're all good. Can you compose this way? No, you can't. You can't compose function this way. You can compose function this way.
Okay.
Yeah.
So in for example Lodash, the normal Lodash, they generally call method called chain. So you change an object, then have apply a few methods to your chain object. So that is the second.
That's the second way. Yeah.
So
that means your it's not obvious here the example, like because array, right? You already have an array.
Yeah.
Now what if you don't have that array yet? Or you're working with something which is lazy, it's not available until the last minute. Then you need to compose your function and then invoke it in the last.
Yeah.
All right, so what we're doing today is actually looking at more things like list, which are functors. Just a side note here. List is a functor, but list contains type A is not a functor. Well, the terminology, list is a functor. Okay, if you the FA here is not because it's already concrete. The list itself is a functor. All right. Okay. So this is the part. I'll just create an empty file. This is the part we handcraft certain type. The first type is maybe. And in the meantime, we need to learn how to use this library called Degi. Okay. Maybe it's used to express a scenario that you have nothing or you have something. Remember last time I said there's no undefined, there's no null in functional programming because they are expressed by types. Maybe a functor has two way to construct it. One way is to say a constructor may be using nothing. The other way is I use a constructor called just to give the value to say this is just this value. Now, how do I use it? This is a very normal way to do functional programming in JavaScript using this library. So let me just write it. It will be clear afterwards. So I'm constructing a maybe type class, and it has two variations. One is nothing. It takes no parameters. The other one is just. It takes one parameter, let's call it x. What does this mean? Now, the maybe here is a tagged sum. What is tagged sum? Now, last time I said the tagged in functional programming will surface again. Here's another place. These are tags. Those two things. Nothing and just. Right? I'll put everything together in the end. Sum means it's either that or that. Okay? It can't be both these two things, but either that or that. What does this mean? if we express in a different way in another language, maybe is actually, well, it's pseudocode, I think, or just something. Yeah. So, well, it's actually maybe A equals to that. The type is this. These are constructors. Using these constructors, I have no inputs, right? That means I couldn't possibly express any value at all. And these constructors takes one value, any type. That means I can only express this thing passed in, right? That means just this thing. Yeah. How do I use this maybe? The maybe nothing, because the empty array here, this nothing is actually a value already. It's not a function. This thing takes a parameter, let's say string 1. That means just 1.x equals that. Yeah. So with this line of code, you basically can figure out how this library works. That means just is a function. You can also call it like this. Yeah, but it's actually a function, just a function. It takes one parameter because it has one value in that array, one element in that array. That means it can take one parameter when you construct it. Yeah, and this value will be passed to the x.
It's just the one is 1, or just 1.x is 1.
Just 1.x is 1. X, it's just 1 is kind of like this.
Oh, okay.
Because the string here x, so the parameter here is named x. I pass to the place that for the just, right? The first parameter is 1 passing to this first element, which is x.
Yeah.
That means whatever object you produce here, we have the x equals to 1. It's just a really simple way to construct things like this using this library. Yeah? And you can do maybe nothing is, this will be false. So just 1 is not nothing. Okay. Well, obviously, maybe dot nothing is maybe dot nothing. That's true. I think it's a function. Or let me just have a look. Maybe later we'll find out. Okay. So it's not a functor yet. It's just a type definition. To say this type can be constructed in 2 ways. One is just do that. One is using maybe.just and pass a argument here. Okay. How to make things a functor is give it a method called map first, right? That's at least you need to satisfy that. Maybe.prototype map equals to a function. Map is a function, yeah? Okay, so what's the parameter here? We're looking at the second one, right? The second one here. The first parameter will be that, yeah?
A function.
A function, yeah. Okay, so let's just denote with f, a function. Now this is where things get tricky. This dot getter. This is a very standard way. I'll explain that. Nothing. Oops. just okay. What we call this pattern match in JavaScript in this library, pattern match. What it means, it matches this, the whole object, to say, look inside. This is FA, this, right? Am I nothing or am I just? Is basically what Keller does here. If I'm nothing, call this function.
Switch, like switch.
Yeah, things like that. Okay. Yeah. If I'm just, the FA, if I'm just, call this function.
Okay.
Right. The tricky part is, for nothing is very easy. Because you have nothing to map over, right? You just return another nothing. There's no empty here. There's only nothing, yeah?
Yeah.
Here, what's this function? It actually gives you the value inside this. So, give you this value as the parameter here. Okay. So here you can just say, constructing another maybe with x applied to f. Yeah? Is that clear? Remember, this x here is already taking the container out to reach inside for the value it processes. Because map function, why I use just here? Map function needs to return the container. But the x here is a plain value. Inside the container, this function receive a plain value now. How do I return a value which is fb? The b part is easy, apply the function, right? The function here returns b for you. But to get the f here to wrap it again, you need to call the maybe.just here, which is the constructor for maybe. Okay. Okay. All right. What does this give us? Maybe dot just one. Let me format it. Dot map. This will be equivalent to maybe dot just. Yeah. Okay, let's explore. Here it gives me just one, right? Okay, this function has nothing to do with maybe. A to A concat string 2, there's nothing to do with maybe, only with the value string, right? So 1 concat 2 is 1, 2 here as a string. The map says, bring this structure of maybe down, give me the value inside. Okay? So the 1 here, the A will be the 1 here once called. The 1 concat 2, it will be 1, 2. So that means you can express a binary situation here. Let's say nothing. Oops. Don't map. Let's put same function here. This will give you. Because when it's nothing, it does nothing. It gives you the nothing again.
Yes.
Right? So what does this express? When you have your program running, your computation, in certain stage you have nothing, and if you keep mapping functions, it will not be it will not continue. It will just skip those functions, right? That means if you map again to say a
So you
Dollars.
still nothing.
it will still be nothing. It will not even call this function.
Okay.
All right. So, of course, you can write it in point phrase style. In Lambda, if you import map from Lambda, let's write it in a different way. So that will be map. Let's do this one. Right. This function is equivalent to those two lines. Right. Now, when you look at this, it has nothing to do with maybe yet. Yeah, these two lines. It only tells you it deals with a particular functor, because map is available on functor. It could be deal with list, could be a maybe. I don't know. But what I do know is whatever functor, it contains string first, and then will be transferred to integer in the end. Right. So now we pass it, for example, maybe dot nothing, it will just give me nothing in the end. If I do maybe just 1, it will be 2, number 2 in the end. Right. If I give it a list of 2, 3, it will give me here. It will give me what, like 2, 3. It will be 2, 2, and 2, 3, 3, 2, and interesting here. What's going to be here?
2.
2, 2. Yeah, 2, 2. Okay. We're not done yet. There's a law regarding functor. It's the fusion law, which means those 3 lines from here to here equivalent to yeah. All right. So you sort of thinking about this in algebra. You have like you're learning primary school maybe.
Something like that.
Like yeah. So B plus C is equivalent to a
production or something.
Yeah.
I remember.
yeah.
Yeah.
Yeah. So if you do map, compose, something which is equivalent to compose, well, in the reverse, you can do map, and compose this. Yeah. So that's kind of the law you need to obey. So if you make something a functor, you need to satisfy this law, basically.
I got a question.
Yeah.
How do you change in the line 17 to 18? 17. You just the one. Then you take the output. You change another map. So, where did you define how? I mean, that is FantasyLand. Is FantasyLand?
FantasyLand, yeah.
FantasyLand. It would at second approach, right? I mean, it's to take
that's
output,
correct.
input into a map. So if in Lambda this one
In Lambda,
you have to just
in Lambda,
compose it and map it like that way.
yeah, you will do one of them. Yeah. Here, because map is defined on the top prototype, you can. This is basically create an instance of type maybe and type just. There's a hierarchy here. The library actually, if you ask if you assign a value to these two lines, the just one, and ask what's the is that value a maybe value? Yes. Is that value a just value? Yes. But is that value a nothing? No. Okay, you can actually ask is it maybe or is it just? Right. Okay.
Also, the just and nothing is we define by ourselves. It's not in DAGI, but we just made
Yes.
just and nothing as our own type.
Yeah. Yeah. So this is the text sum is basically an algebra data type. It's the sum type here. There's another method called DAGI.tag, which you name it as say tuple. And then basically you say 1 and 2 here. That is the product type. When I construct, let's give this type a name called tuple.
So it only have one type in that case.
It contains both types.
Oh.
Right? This equivalent to is isomorphic to So here, what it does is give you a type, tuple, and then it receives two parameters.
Yeah.
The two parameters will be expressed, will be retrievable like this and this. So the first one will be equals to 1, and this one equals to 2.
So the sum type is the same as union type in C++.
Yeah, union, yeah. Yeah, just by different names in different languages. Yeah. JavaScript, well, this library expresses like this kind of construct. Yeah. But product type is not our topic here. Let's stick with this. All right. Here's the maybe. So I got a bit of homework for you guys this time. Well, I already did for you. There's either to express both sides. Either is like this. So we have this maybe, which is very handy. And the either type, either functor, and actually, if I express it, be A equals to left A or right A. It tells us that for maybe A equals to nothing or just A. When maybe express nothing, you don't have any value you can express, right? You can only express the notion of nothing. Yeah. And you can map over it, which does nothing. But either is kind of give you a value you can express. It's like you do something and failed. Oh, now that's error message, for example. You can express that side. So the either contains two types. One is for the left side, one is for the right side. When I say sides, it's purely because this one is on the left of the pipe. This one is on the right. So the mapping on either is actually map the A, not the B. The left B is like nothing. When you call map on it with a function, it does not change the B if it is the left side. If it is the right side, when you map it over it, it's just. Yeah. So the tag sum, I write it. Hopefully you can write at home on the laptop. We had DAGI.tag sum. Right. So here, what's the first parameter? It's the name of the type. which is either. And you have the constructors. Now we used to have nothing and just as constructors. Here we have two as well, right? So we'll be left and right. Yeah. So for the left, I'm to store the left value as a key on the object, right, on the instance. So I give it, let's say, the L, denote left. Right. And here I use R to say, that means if I constant here, either, then
either dot L.
Dot left 1. That means this thing dot L will be 1. Yeah. So when you're doing map here, take a function, it will still be that. It does not change the value inside. Because the left side is like nothing. Even though you have a value here, the map does not touch it. Thinking about your program, you have a program, you have set of instructions, success, success, oh, error, you have an error message here. You want to skip. You want to skip this, skip this, skip this. That's what left gives you. That gives you that error message. And then all the map here, where there's nothing to the data flowing through because it's already errored. Okay. If you have a right side here, into map, let's say this function concatenates 1 into the string, then you will have either right to 1. If this function does concatenation of 1 into the end appending, then it will just be either dot right to 1, the result here. Yeah. Okay. So not the people always often make mistakes when they look at either they're thinking about those two values actually exist at the same time, the left and right. No, it's either right or either left. Okay? Once you have the left, you lose the right value. Yeah? Okay. So, and also the map on the left does not give you anything. There's nothing. It's as if this line doesn't exist. Okay?
So
that's what it does.
So if I treat the error the same way as nothing, does that mean either and maybe they're equivalent?
Only from the either side to maybe.
Yeah.
Yes.
Yeah.
But if I treat nothing as if it was error, so it becomes either, right?
You cannot, because nothing, here's the constructor, it expresses a particular instance of a type. It does not contain a value. So if you go this way, you cannot.
What if all the error message is the same value? Then nothing is the same as left.
Basically, which means you skip the B. So yeah.
You cannot. And the maybe dot nothing, it does not encapsulate any value. But either dot left, it contains a value here.
Yes.
So if you go this way, you're losing value. If you go that way, you cannot.
Yeah.
Yeah.
So it just means if you accept any E, it will be the same as the nothing.
Yeah. So if I don't care about the error message,
then
say
you have,
I treat all the error the same.
Yeah.
I don't really care, then it's the same.
Yes, that's right. Yeah. That is also from the library Functor has a from IPHER from either a function, a method on instance of maybe. You can pass it either value, it spits out the maybe value for you. Yeah. I think that's gonna be today. I do have the entire definition in the file, maybe here. So the map, the data definition, data type definition, and the map function. And what's important here is get or else. So at certain stage, you want to get the value outside maybe to use it. Right? You can't use the maybe like a container. Like for example, you want to use a particular value inside the array. You need to, peel off the container and get the value itself. Yeah. So the get or else is actually that. What it does is, for example, maybe dot just 1. You do get else 2, it will be 1. And if you do maybe nothing, get else 2, it will be 2. It provides the default value in case you don't contain a value.
Okay.
Right. Otherwise, you just retrieve the x,
So just
give it to you.
put the state.
Yeah. So you just peel off the container. Here you go. That's the real value contained in there. Yeah. So that usually happens at the last stage of your program when you want to display it or send it over network. But in certain scenarios, you don't need that, because if you can make those constructs serializable, then you can send it over network and you can serialize them. And Functor has that capability as well. Yeah. So have a look at this file. And next time we'll talk about more of either. We'll finish the definition, so it will become like this, and more things. And maybe it's not only Functor. It is also other things as well, even a Flodable. So we'll talk about that later. And there's another one called Promise. It's not ES6 Promise, which is a Functor as well. You can have a look. Next time we'll go through that as well, and the difference between ES6 Promise. Yeah. All right. Cool.
So maybe today we implemented is just to using DAGI to simulate the Haskell maybe manually using this library.
Yeah.
It doesn't available in JavaScript. So we
yeah, there's many libraries that does the same, but I find that using you handcraft those things will be for your understanding will be beneficial.
Yeah.
Okay. Yeah. All right. Okay. So that's it for today.